Welcome back to the night class. Today we're going to study exponential growth and decay. That's lesson 6.4 in your textbooks. Basically, you need, on page 314 in your book, it tells you, it gives you the form here. So I'm going to write it up here. Y equals A times 1 plus R to the, do they say X power? Yes. I'm about to explain all that, okay? And again, these are just variables, okay? The letters don't really matter as much as what you're plugging in for the letters. And I put X. I think I should have put it. Yep, I should have. I'm sorry. That X should be a T.
T?
Yes. Hi, Jasmine.
I don't think we're supposed to.
Not X, sorry. T. But like I said before, they're just variables. Could I have put X there? Sure. But they want it to be a T so it'll help you remember something. Okay? So this A right here, okay, that is how much you have to begin with of whatever you're talking about. Okay? R stands for your rate. Okay? And what do you think T stands for?
Exponent.
What does T usually stand for?
What now?
Time. Okay? T is time. All right? This is an exponential growth and exponential decay. Okay? Now yesterday we did this, okay? A times B to the X. Okay? That's an exponential function because remember what makes an exponential function? When you have a variable in the what? Exponent. Okay, so this and this are related. All right, the only difference is what is B in my problem, basically. Here's B. What's the B over here?
The R?
The 1 plus R.
Oh.
See, the parentheses is your B from yesterday. Okay, but it's basically the same thing. It's basically here. It's one thing.
That's a 1. I thought it was
One, yeah, that's a 1. 1 plus R. Okay, so this first example we're doing, it says the inaugural attendance of an annual music music festival is 150,000 people. Okay, the attendance Y increases by 8% each year. Part A, they want us to write an exponential growth function that represents the attendance after T years. Okay, so all you have to do is plug in what they've given us, okay? How much is the attendance the first year?
100. Whatever that number is.
150,000.
So that's my what? That's my A. That's how much I have to begin with, okay? It increases by what?
8%.
8%. What is that?
R.
That's my R. That's the rate at which it's increasing, okay? Does that make sense?
Yeah,
So that's my R. And then they want us to write an exponential function in T years. So did they tell me how many years yet? No, we just put, not in part A, okay? They will in part B, but in part A, we're just gonna leave T as T, okay? So here we're gonna have Y equals, what is A?
150,000.
150,000 times 1 plus. What is R?
Oh.
It's not 8 though, you have to change it to a decimal. It's 8%, which is 0.08, okay? And then to the T power.
So you don't do anything with the 1?
Then we can reduce that just a little bit. 150,000. What is 1 plus 0.08?
1.08.
1.08 is correct. Okay? So that's part B. Part A, excuse me.
Isn't that the full, like the 1 is like a 1.00?
Yeah, it's 1 plus 0.08, so it's just 1.08. Okay? Now, can y'all tell, now that we've simplified it, it's even more like it was yesterday. Okay, so what's my B? 1.08 is my B from yesterday. Is that making sense? Okay, because we've already added them.
I need a custodian to report to Ms. Foster's room.
Okay, so there's our equation. B, how many people will attend the festival in the 5th year? Round your answer to the nearest 1,000. So we just need to plug what in for T? 5. So Y equals 150,000 times 1.08 to the 5th power. And put that in your calculator.
I got the wrong answer.
Oh, it is wrong. Hold on, I'm sorry. I messed up. It didn't say 5 years later. It said in the what?
50.
In the 5th year. So that's my apologies.
You don't do specify.
You don't, you put what? Because the first year was what?
150.
That one. So you have to put a 4.
Oh.
You got me?
So when it says like 6, you have to put a 5.
It's all in how it's worded, Katrina.
Okay.
Okay? Because there will be some times where you do put the 5.
I got
It's
it.
all in how it's worded. The reason we did it here is because it said the inaugural attendance. So that means that was the first year. Okay?
Okay.
So the second year, all right, what I'm trying to say is if I plugged in 1 for T, right,
Okay.
I would actually get the second year's attendance
Oh.
because I'm multiplying the first year's attendance by the 1.08. If I wanted the third year's attendance, I'd have to plug in 2. If I wanted, see what I'm saying? It's the 5th year is 4 years after the first year. So that's why I'm putting in the 4. Okay, and again, when we come to a problem where you can just plug it in, I'll show you the difference. Okay, a lot of times they'll start because we're growing right now, but sometimes it decays. Notice, you can grow and you can decay. Decay means you get smaller.
So would you put it
Okay.
like a minus sign?
Exactly.
Like a negative.
It's no, you're right. You would, instead of saying 1 plus 0.08, if it had said decreases by 8%, we would have said 1 minus 0.08. Okay? But then we do the same thing. All right? My number in the parentheses, though, would be less than 1. So as long as that number is less than 1,
Would that
it's
number
gonna
always
decay.
be positive?
it should always be positive, yes. If that number is greater than 1, you know it's going to grow. All right? But yeah, we'll get back. So what is 150,000 times 1.08 to the 4th power? 204,000.
73.
Point 0.34. But technically, you can't have 0.34 of a person. So we're just gonna leave it as 204,073 people. Okay? Any questions?
So that's 8% code?
That is an 8% increase
Yes, sir.
for 4 more years. Okay? Not in all. That would be a bigger increase from year 1, but that's an 8% increase than it was in year 4. Okay.
5 years.
It is. This would be the 5th year.
Okay.
All right. Questions on that? Pretty simple. All right. Let's try another one. A little different this time. Sorry. Is that big enough? Y'all see that?
Yes, sir.
Okay. This time, part A. Same process. Write an exponential growth function that represents the attendance after T years. Exact same instructions. How much do we have to begin with this time, though? 80,000. So y equals 80,000 times 1 plus, what's my increase?
6%.
6%. So I put 0.06 to the T power. Simplify that just a little bit. What is 1 plus 0.06? 1.06 to the T power. That is part A.
And then
Are
do
we
y
gonna always
equals.
have to do that? Like part A than part B?
Probably.
And then y
Just depends on what the directions say. Okay? How many people will attend the festival in the 5th year? Again, so this 5th year, I don't know why they did the same one. So what are we going to plug in for our t? 4. So y equals 80,000 times 1.06 to the 4th power. You should get, if my answer is correct.
Don't you say it, Coach.
I'm not going to say it. I'm not going to say it.
Oh, that's a lot. 100,099. 1,998. That's what I meant to say.
100,000?
998. We got a lot of questions for homework. 6 through 16. Every third problem.
And that's people, right?
18.
What's
16 divided by 3? I thought it was like 30.
20? It's 20.
100,998 people. That is correct.
We have a problem. I just decided to turn on my calculator for a little bit.
All right. So we're back. Our next one.
You know what'd be funny? If somebody does something bad in here and you had it on video,
I know, that'd be
you
great.
could like show the office, be like, yeah, see, I ain't lying.
When we go to court. Look, I told you he said this to me. Okay. Determine whether each table represents an exponential growth function, an exponential decay function, or neither. Okay? So this is pretty, I guess, common sense. If it's going down, it's what? Decay. If it's going up, it's what? Growth. Or could be. Because remember, they're saying exponential, right? It could be going up, but not be exponential. Remember? How do you know? How do you remember if it's exponential? You're either what? Multiplying by something or dividing by something. Okay? Dividing would be decaying, right? Multiplying would be growing. All right? So here, obviously, what are the y's doing? They're going down. So it's decaying. We have to figure out, is it decaying the same amount every time? 270. Well, I like starting with the small numbers first. So what's 30 divided by 10? 3. What's 90 divided by 30? 3. What's 270 divided by 90? 3. That is exponential decay. Because we are dividing. Okay? It's like, really, we're multiplying by one third. Okay? That's what we're multiplying by. But multiplying by 1/3 is the same as dividing by 3. Everybody with me? Okay. What about here? It's not decay, so it's possible growth. Is it multiplying by the same number every time? I think you're right. It is. So that is definitely exponential growth.
So it only matters by the y, not the x.
Correct. The x does matter. You just have to make sure the x is changing the same amount every time. It's just going up by 1, or it could be going up by 2, or it could be. But as far as multiplying, that's not what you're looking at. You're looking at the y to know that.
Could the y's be like all the same?
They could be, but it wouldn't be exponential if they were. Okay. This would be an example of one, like you could have x, y, and this is kind of what I was talking about. So this one, it's increasing, but it's not growing. It's not exponential growth. It's just increasing by, we're adding 2 every time, not multiplying by 2 every time. Okay? So if you get one like this one would be an example of, well, it's not doing either one. Okay? It's neither, because it's not even exponential at all. You got me? Okay? Questions on that? Everybody good? Yes, sir.
Couldn't it do like on B? Couldn't it say like X could go 0, 1, 2, 3, and then 5, and then Y could go 5, 10, 20, 40, then 160?
Yes.
You can do that?
You're getting advanced there. If it went to 5, then we would probably be multiplying by 4 to get that next. See what I'm saying? They just skipped 4, but for our purposes, they shouldn't do that. It should be in order. Okay. for this lesson's purpose, I don't think they'll give you any like that. Okay?
Can you give us one as a bonus on the test?
Maybe. We'll see. Try that one. What do you think about A?
Exponential decay function because it's dividing by 2.
It's dividing by 2 every time. So that's a decay. What do you think? That's a growth. By what? By 10. Times 10 times 10 times 10. You don't. That's just extra that I'm asking. Okay? So exponential decay, exponential growth. Everybody good? How to tell the difference, right? Beautiful. You are. Oops, wrong one.
Did you have to, what's Miss main one? Is she like a same thing as this?
No, she's a foundation.
So if you
But
if you
basically the same
know
thing.
that, you come in here.
Well, now
This is no. We're just getting you ready for algebra 2.
Some kids in my grade, they just went straight to algebra.
Gotcha.
Because
All right.
algebra 1 and 8.
I was pointing one.
Here we go. Same question. Same question. Okay. But they gave you a equation rather than a table. Okay. So how do you know if it's growing? I mentioned this earlier. Let's see how many of you are paying attention. How do you know if it's growing or not? What number do we look at?
One.
The one
The one that's in the what?
the parentheses.
The one that's in the parentheses.
See, it's over.
Okay.
Well, that would be.
That one's what? More than 1 or less than 1?
More than 1.
That's more than 1, so that would be a growth.
And the other one's decreasing.
This one's less than 1, so it is a decay.
Do you have to write growth, or can you just write increasing?
No, it's what's asking. Determine whether each function represents exponential growth or exponential decay. Okay? It also wants you to identify the percent rate of change. So they want us to find R. Okay? Now R is easier to find on the growth ones than it is on the decay ones. Okay? Because with the growth ones, you can really just kind of look. What was R on the growth there?
0.07.
0.07.
I need Raylan Charleston to come to the front office.
So 0.07 would be what as a percent?
7%.
7%. And all I'm looking is how much more than 1 is it. That's all you're looking at. Everybody see that? Okay? But on the decay, now you're not looking at how much more than 1 it is. You're figuring out how much less than 1 is it. So how much less than 1 is that? What? 2%. Okay? Because how did I do that? I said 1 minus 0.98, and I got 0.02. And you change your decimal to a percent. Easy enough? Okay? What if the number in there is 1? Just 1?
Well, then it should be neither.
It's neither. It's not going to grow or decay. It's just going to stay. It's going to stay the same. Because when you multiply something by 1, does it change? No.
So what if it's
7
like-
times 1 is still 8 times 1 is 8. 101 times 1 is 101. Okay? If you multiply it by 1, nothing changes. But if you multiply it by a number bigger than 1, it gets bigger. If you multiply it by a number smaller than 1, and I'm not talking about negative numbers, I'm talking about just decimals, okay? It's decreases, okay? It decays.
What if it's like 1.01?
Then it went up 1%.
Oh.
Okay? Yes, sir.
When a business says like our company grew 250%, do they mean it just went up like 2.5?
No, I
If
mean,
you like point,
well, yes.
is
I see
that-
what you're saying. Yes. 250%,
Yeah,
okay, would be multiplying by 2.5.
okay, I was making sure.
Yes.
Because I was like, if you have let's say you have $100 million company, they say it went up 250%. It only went up. Now it's only up 250 million.
I like using normal numbers.
Like
Okay.
using normal.
So let's say our company is worth $100.
Yeah.
Okay. If it goes up 100%,
Yes.
now it's worth $200. Not okay. All right. If it goes up 200%, now it's worth $300. Is that making sense?
Yes, sir.
Okay. If it goes up 150%, well, now it's, you multiply this, okay, by 1 or 2.5, because 100% means it increased by its value. Okay, so 150% would mean it increased by its value plus 50% more. So the value of it's 100 plus the 50% more. So now you're at 250. Is that making sense?
Yes.
Okay. All right. Let's do another quick one of these because they're really easy. What do you think? Decrease or increase? Increase. So it is a growth, right?
9%.
Oops. Growth by 9%. This would be a decay.
And you would subtract 9.
How much less than 1 is that? 7. Okay? Easy enough? Not 70, 7. It would be 70 if it was 0.3 in the parentheses.
Now, how do you get that again?
That would be 70 because you'd say 1 minus 0.3 and you would get 0.7, which is 70%. Okay? 1 minus 3. Yep.
And it did the point.
Yeah, you did 0.03. So now that's back to being 7%. But 0.3 would be 70%. Okay? All right? Everybody good on those? Beautiful.
Oh, I see it now.
Example 4.
You do the one with answers.
All right.
Oh,
A little harder. Okay? These are a little harder.
There's a fraction.
So there is a fraction out there. Okay? So we can't look at this number yet because we don't have just t on the outside.
You have
Okay? So watch what I'm doing carefully here. Okay? I'm gonna it says to rewrite it. Okay? So I'm gonna rewrite this. 100 times 0.96 times 1/4 t. Okay? Or I should say times t. All right? Now, we did this the other day. When do you multiply exponents? When you take an exponent to another power, a power to another power, right? So this 1/4 can actually go inside there. So you would write it,
parentheses.
it goes inside the parentheses. You would write it like this, 0.96 to the 1/4 power t, to the t power. And now we can take that 0.96 and put it, I'm going to use your calculator on here. We can put it in our calculator and actually figure out what this is, okay? So 0.96 to the, to the 1/4 power. Now, that's the decimal I want to work with,
When you round it
okay? You do round it,
to a 1.
and round it, no, you don't round it that much, because we do want, it is a decimal, okay? I'm just going to round it to 0.99, okay? So, what does the book round it to? Let me look, see if I'm rounding it the same as they are. The book rounds it to, yeah, 0.99, so
Calculator charging right there.
they aren't,
How are they charging?
they're not,
The chargers?
they're not charging. Chargers are on the bottom.
How are
They're
they
just sitting there.
charged?
They are charged, but they're not charging at the moment. All right, so I'm going to change that to 0.99. So let me go back to our problem here. This will become y equals 100 times 0.99 to the t power. And now we answered the question. Growth or decay? It is a decay.
So confused why wouldn't you round it though?
Because then you just have 1 minus 1.
But then it would be neither.
It's not neither though. It went down what? 0.01%. Or 0.01, which is 1%. Okay? It decayed 1%. Now that's not a lot of decaying, but it is decaying. Okay? If we put neither, there you're saying it doesn't, it stays the same, which is not true. Okay? Over time, it will eventually get smaller. Okay? It might take a while, but you're not going to end up with the same amount that you had when you started. All right? So on part B, we can go a little quicker here. Part B is going to be 1.1 to the t minus 3 power.
There's an F.
Okay? All right. Oh, is it f of t? Oh, sure is. I'm sorry. Thank you. F of t.
They changed it.
They did. It technically it matters, but really it doesn't really matter. Okay? So again, this one's even a little harder. What are we doing with these exponents here?
Close them in.
No, what's that say? T what 3? T minus 3. What do we usually do when we're subtracting exponents? What do we usually do?
Put it on a plot and you try to make.
Okay, that's when it's negative.
No, you add the positive. No, I can't remember.
I want to write it up here. Okay? For those of you at home, I'm writing t to the 6th divided by t squared.
You subtract.
What does that equal?
You subtract and you
It's t to the 6 minus 2, which is t to the 4th, right? So I'm asking you to kind of work backwards here.
get.
Okay? So what was my problem before this? It was 1.1 to the t over 1.1 to what? The 3rd.
Would it be the second?
Okay?
Well, we don't know what T is.
I know. We don't have to know what t is. We're just trying to get the t alone out here. Okay?
Then what's- oh.
Now, what part can I put in my calculator? And you're right, you can't put the t part in there because do we know what t is?
No.
No. So it just stays 1.1 to the t over what is 1.1 to the 3rd. Can we put that in our calculator? Yes. So let me erase that for a second and come back down here to my calculator. 1.1 to the 3rd. I keep hitting that dividing sign. That is 1.331. Okay.
Definitely over
1.331. So this becomes now 1.3. I done messed up. 1.331. All right. Everybody with me so far? What's my A?
The 1.1 T.
No, I would have gone
Check the original.
I'm gonna, I wish I could erase it. Can I move this up? I can't. Okay. Here, I'm gonna come up here because I'm running out of room down here. Okay, now it's up here. I can write this f of t equals 1 over 1.331 times 1.1 to the t power. Think about it. If I put this in parentheses, right, what's out front of it? 1. So it's like saying 1 over this, you with me?
Mhm.
Would be that. And I can put that in my calculator. And I get, I'm rounding again, 0.75 times 1.1 to the t. Now, I sure am worrying about this a whole bunch. But do I even need that to tell whether it's growth or decay?
It's decay.
I'm not, remember, I don't, what's in the parentheses tells me whether it's growth or decay. So that's what I'm trying to get you to understand. We're spending a lot of time on this, but should we? No, because it doesn't, for what the question has asked, it doesn't matter. We are growing by what? What's my rate?
What's in the
How much bigger than 1 is it? It's 1, it's not 1%, it's 0.1, which is what as a percentage? It's 10%.
0.10.
Okay? It is 10% growth. Okay? 10% growth. So, all you really got to remember here is if it's a minus, I've showed you all this so you can see the shortcut here. If it's subtracting, do you have to go through all this about moving it and everything? No, because it's this part that's in the parentheses isn't going to change. Okay? What if it's adding?
It doesn't matter.
It's not going to.
It's irrelevant.
Good question. All right. Next example. What was that? 4? How many more we got? Okay. I think we're going 5, maybe 6. Here we go. Now we actually get to use this stuff that we're learning here.
Deposit 100. I can't read.
I know. I'm trying to move it where you can. There we go. There we go. On page 317, there is a compound interest formula. Okay? Compound interest. This is the compound interest formula. Again, it's on 317. Y equals P times 1 plus R over N to the NT power. We got more variables. Okay? Now, when you compound something, what's that mean? Yeah. Like if I have, let's say, I'm going to go below the line here just because it makes for good examples. Okay? I get pulled over for speed. Okay? Now, I get pulled over for speeding, and while I'm being pulled over for speeding, okay, I get in an argument with the officer, and he's like, "Oh, well, you also didn't have your seatbelt." So now, because I argued with him, what have I done to my problem?
Made it worse.
I've compounded the problem. I've made it worse. Is that making sense? Whereas I could have just said, "Yes, sir, here's my ticket." And if I had a gripe, I'll just fight it in court or whatever. You see what I'm saying? But no, I had to make my point there, and now I've compounded it, and now I've got 2 tickets rather than just 1 ticket. Does that make sense? Okay, exactly. So I've compounded the problem. That's kind of what interest does. And it can be a good thing or it can be a bad thing, okay? If you're in a savings account where the bank's paying you money to borrow your money, compound interest is a good thing, okay? So what does this mean? This means simple interest. I put in $1,000, okay? I let the bank borrow $1,000 from me for a year. At the end of the year, they promise to give me 10% interest, which you're not going to get that, by the way. That's way too high. You're lucky if you get 1% interest. But anyway, 10% interest. 10% of 1,000 is 100. So at the end of the year, I get I have $1,100 now. Okay? If it's compound interest, let's say it's compounded monthly. Well, now through that year, every month, I get the $100. Okay? And so after the first month, I have $1,100. Okay? After the second month, guess what? They don't give me interest on that original $1,000. They give me interest on the new amount I have, which is $1,100.
Wouldn't it be
And then
12?
on the third month, I get interest on that new amount. Okay, so that's what compound interest is. Regular interest, you're just getting interest off of the original amount. Okay, compound interest, you get interest on top of your interest. Okay, you're getting interest for your interest.
Like ads.
Exactly. Okay, so here is the formula. Notice it's similar to the original with one new letter. What's the one new letter? N. N, and it's in two places. N is how many times it gets compounded. Okay? So if I told you I'm compounding it monthly, what would N be?
The month?
What number would it be?
1.
No.
Whatever you put your interest in.
If I said I'm going to compound this monthly, what number am I going to put in for N? 12, because how many months are in a year?
Oh.
12. If I said I'm going to compound it daily,
364.
5.
5.
N's going to be 365.
Unless you
Okay.
skip fathers.
If I say I'm going to compound it weekly, how many weeks are there in a year?
52.
52. So N's going to be 52. If I say, and this is the tricky ones, if I say I'm going to compound it quarterly,
Every 3
That'd
months.
be, yeah.
it's every 3 months, but that's not what how many times would it be compounded if it's
Oh.
quarterly? 4. Every 3 months is correct, but there's 4 times. Okay, think about it. Quarterly, how many quarters are there in a dollar? 4 quarters. Okay, right. Okay, so N would be 4 if it's quarterly.
Okay.
If it's bi-monthly,
30.
that doesn't mean that doesn't mean twice a month. That means every other month.
Yeah.
Okay, so some people get that mixed up. They hear bi-monthly, that means, oh, I'm doing it twice a month. No, that means every 2 months. So what would N be? 6. Everybody follow me there? Okay. Otherwise, everything else is the same. So here, I'm starting out with how much? $100. Now notice my A has turned into a what?
A P.
A P. Anybody know what P stands for by any chance?
The thing you just said?
Yeah.
Yeah.
Principal. Now we're not talking about Mr. Huey here, okay? But the principal is how much money you invest in something, okay? So that's my A, or my P in this case, all right? What's my rate? 6%, so that's my R. And I'm compounding it what? Monthly. That would be 12. And after that, it's just plugging in.
12
Y equals, what's P?
100.
100 times 1 plus, what's my R?
6%, which is 0.6.
0.06, okay? Divided by, what's in? 12. To the 12 times T power. Ta-da. Done. Okay? That's going to tell me how much I'll make depending on how many years I keep it in. Okay?
23 years.
All right? 23 years. That would be a lot of money. Well, I say a lot. It wouldn't be that much. We only start out with how much? 100. Okay? So after 23, well, I don't know. Let's see. Type it in. Let me see here. 100 times 1 plus 0.06 divided by 12.
That wasn't me.
To the 12 times, what did you say, 23 years?
Yes, sir.
After 23 years, that $100 has become almost $400. It's $396.13. Okay?
No, that's not even enough to buy bunny rabbit.
It's not that much, but again, we only invested how much to begin with? $100. Y'all ever heard it takes money to make money? That's kind of what it's talking about.
You
Okay?
taught us more about banking than any other
I'm happy.
history teacher, any teacher that deals with that in a year.
Let's try another one. Okay? Let's try the next one. Same process. So what's my formula going to be? Y equals, how much do we start out with? 300 times 1 plus, what's my rate?
3.
So 0.03. How many times am I compounding it?
Monthly.
Monthly again. I hate how they use the same. I mean, we just did that one.
Can we do
12.
yearly?
You can do. If you do yearly, what's n going to be?
It's gonna be, no, it's gonna be
300.
Just one.
Just one?
Just one. That means you're only compounding it one time a year.
Oh.
Okay? That makes sense? All right. 12 to the t power.
So what if it was like 10 years?
every decade would.
Then you would put 10.
10?
Oh, like once every 10 years?
Mm-hmm.
Now you're getting harder. It would be 1/10 t.
1/10?
Correct. Because you don't get to compound it until after 10 years. So you need how many years? What does t have to be before it gets compounded? 10.
Oh, 10.
Okay? And 10 times 1/10 would be 1. Okay?
That would be nice, though.
It definitely would be.
You sit there and
It'd be a-
you put.
It would be nice.
$5,000 in, you
Okay.
sit there
Now,
and they'll show up.
we can reduce this. Okay? And I should have reduced it a minute ago. 12, it'd be 300, because we can put all of this in my calculator, and we can even take it to the 12th power. Okay? But we can't take it to the t power. So let me see here. 1 plus 0.03 divided by 12 to the 12th power. That's 1.03 to the t. Okay?
And then you just.
Which is pretty close still. All right?
1.03.
Correct.
Since the parentheses equals time.
Any questions? We're going to do, I think, one more example. Yep. You got one more? You got a question?
What time do we leave?
In
121.
25 minutes. All right.
I forgot.
Our last one. The table shows. This is a money market account. Okay? So you can get these at the bank. A money market account, it's like a savings account, but different. Okay? There's different kind of accounts you can get. If you just get a regular savings account, you can take that money out and use it whenever you want to. They have things called CDs. Okay? CDs you can take out when you want to, but
It has to be on.
you have to pay like a penalty. Like if you get a CD, let's say you're getting a 12-month CD, you're promising the bank that you're going to put this money in and you're not going to touch it for a month. Or a month. For
10 years.
a year. Okay? For a year. 12-month CD, you're not going to touch. You're going to let them borrow it for 12 months and not touch it. Now, if something happens, emergency, and you need to get it, you can get it, but you usually have to pay the bank like a fee. If you you're making an agreement with them.
You're making money.
Okay.
Money
They're paying you to borrow your money. You got me? So if you think you're going to need that $1,000 or whatever, a CD probably isn't good. But if you win the lottery or something, okay, and not like the big lottery, just like say you win $5,000. Oh, I'm going to put $1,000 of it in the bank and I'm not going to touch it. You can go get a CD and they'll give you a good interest rate. So at the end of that year, that $1,000 is now $1,200 or $1,300. And they paid you that much money just for letting them borrow your money. Okay?
Borrow my credit card.
Because it works the other way too. They let you borrow money to buy things like a house or a car or whatever, and you have to pay them back plus interest. Okay? And that's how they make money. That's how banks make money. Okay? So, it says, write a function that represents the balance after t years. So, we're writing a function that represents the balance after 2 years. So, I'm on page 317. So this is just y equals p times 1 plus r to the t power. Notice, I didn't do the ends because does it say anything about compounded?
No.
It doesn't say anything about compounding. Okay? So this is just your regular interest rate. Okay? So how much do I have to begin with?
$100 bill.
$100.
Just the regular, why is the piece of?
Because it's still principal. Anytime we're talking about money and investing, they usually use P for principal. Okay? So 100, 1 plus, well, here we got to figure out how much did it go up from 100 to 110.
You know,
It went up $10. $10 is how much of my original?
10%. So,
No.
10 divided by 100. What would that equal? 1/10.
1/10.
So it is,
All right, correct.
why are you gonna look at me like I'm not?
because I want you to be sure you're right. 1 plus 0.1 to the t power. Okay, can I add the 1 and the 0.1? Somebody say yes.
Yes.
Yes. Okay. 1 times 1.1 to the t power. That's what y equals. That would be part A. Okay. Part B. Graph the function. We won't worry about graphing. Okay. So all you had to do there. Any questions? Okay.
All you have
Real quick review. If this number in the parentheses is bigger than 1,
growth.
it's growth.
Oh,
Less than 1,
down.
decay. Okay. Change your rates from percentages. Always change them to decimals. Or if it asks you for the rate, you're probably going to have to change the decimal to a percent. Okay. All right. Any questions? Awesome.
Yes,
We'll
the 5. How in the darn did they get?
the 5. Here?
Yeah.
Oh, that's just the 5th year. Look, they took $100
Wait.
times 1.1. Got 110. That was that year. Okay, the next year, how much we got now? We got 110. So they took $110 times 1.1.
Yes, again.
And now you got 121. Well, now how much we got? So we took that and multiplied it times 1.1. Now we got that much.
Oh, okay.
And then we took that and multiplied it by 1.1. And now we got that much.
I'm getting old.
And then we took that one and multiplied it times 1.1. And finally we got on year 5, $161.05. Okay? So in 5 years, out of that $100, we've made $61.05. We've made $61.05 so far. Okay? Hope y'all enjoyed the video. I'm about to cut it off. See you next time and stay above the line.